So my dear students, again warm welcome in our next section, that is measures of central tendency. Earlier in this chapter we represented the data in various forms through frequency distribution tables, bar graphs, histograms and frequency polygons. Now the question arises, if we always need to study all the data to make out some important aspects of it by considering only certain representatives of the data. No doubt this is possible, but by using measures of central tendency or averages. An average or a central value of a data is the value of the variable which describes the aspects of the entire data. Or in simple words, we can say an average of a distribution is the value of the variable which is representative of the entire distribution. Such a value is of great importance. Why? Because it depicts features of the entire data. Since an average represents the entire data, therefore its values lies somewhere in between two extremes, that is the largest and the smallest items. For this reason, an average is called a measure of location or a measure of central tendency. Now basically, the commonly used measures of central tendency are: first one is arithmetic mean, second one is geometric mean, third one is median, then harmonic mean, and last mode. But here we shall study only the arithmetic mean, or we can say simply mean, median and mode. Now let's start our first component, that is mean. What is mean? Mean is nothing but it is the sum of the values divided by the number of values. Let us take an example for this. What is the mean of these numbers? That is 7, 11 and 7. Firstly we add these values, then it comes to be 24 and finally divided by 3. Why? Because there are total 3 numbers, 6, 11 and 7. So finally it comes to be 8. So the mean of the above numbers 6, 11 and 7 is 8. Moving to our next example, we have given the following series from 3 to 29. The solution of this following series is, the sum of the total numbers is 330, that is 3 plus 7 plus 5 plus 13 plus 20 plus 23 plus 39 plus 23 plus 40 plus 23 plus 14 plus 12 plus 56 plus 23 plus 29 equals to 330. And now there are total 15 numbers. So mean equals to 330 divided by 15 equals to 22. So we can say the mean of the above numbers is 22. Now let's study about arithmetic mean of ungrouped data. Let's say if x1, x2 and x3 up to xn are n values of a variable x, then the arithmetic mean or simply the mean of these values is denoted by x bar and is defined as x1 plus x2 plus x3 plus x4 up to xn divided by small n, and it can be written as x bar equals to 1 by n bracket sigma xi, where sigma xi denotes the sum x1 plus x2 plus x3 up to xn. In other words, we can say the arithmetic mean of a set of observations is equal to their sum divided by the total number of observations. Here we have total observations from 1 to n. So here we take the value n. Now the next example illustrates the use of this definition in finding the arithmetic mean of individual observations. Let's say find the arithmetic mean of first 10 even natural numbers. As students, we know the first 10 even natural numbers would be 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Now we have to find out the arithmetic mean. What we will do? We simply add these values from 2 to 20 and divide it by 10, because there are total 10 numbers from 2 to 20. So it comes to be 110 divided by 10. So the arithmetic mean of first 10 even natural numbers is 11. Now let's study about arithmetic mean of group data. If a variate x takes values x1, x2, x3 up to xn with the corresponding frequencies f1, f2, f3 up to fn respectively, then the formula for arithmetic mean of group data would be x bar equals to f1 x1 plus f2 x2 plus f3 x3 plus f4 x4 up to fx xn divided by f1 plus f2 plus f3 up to fn. It can be also written as x bar equals to sigma fi xi divided by capital N, where sigma fi equals to f1 plus f2 plus f3 up to fn, and x1, x2, x3 can be written as in the form of xi, and capital N is the total number of frequencies. Now again The next example will illustrate this definition. Find the value of p if the mean of the following distribution is 7.5. My dear students, what we have given in the question, that is, we have to find out the value of p if the mean of this following distribution is 7.5. Here we have two values, that is x and y. We have given the individual values of x, that is 3, 5, 7, 9, 11, 13, and y 6, 8, 15, p, 8 and 4. So let's see how it will solve. This is a table where we have given the values of x, that is 3, 5, 7, 9, 11 and 13. And the values of y, or we can say the value of fi, is 6, 8, 15, p, 8 and 4. What we will do to find the value of fi xi, we simply multiply the values of xi and fi. That is 6 into 3, 18, 5 into 8, 40, 15, 7 ja 105, 9p, 11 into 8 equals to 88, and 13 into 4 equals to 52. So finally it comes to be like capital N, as we have told you earlier also, that the sum of the frequencies equals to capital N equals to sigma fi equals to 41 plus p. And here we have the total of sigma fi xi equals to 303 plus np. So from the table we have sigma fi equals to 41 plus p and sigma fi xi equals to 303 plus 9p. And we know the formula, that is mean equals to sigma fi xi divided by sigma fi or capital N. Here we simply put all the values we have given in the question, that mean is 7.5, and we just find out the value of sigma fi xi, that is 303 plus 9p divided by 41 plus p. We simply solve this equation, and finally the value of p comes to be 3. So we can say here, for the given distribution, the value of p is 3. Now moving to our next component, that is median. What is median? Median of a distribution is the value of the variable which divides the distribution into two equal parts. That is, or we can say in more simple words, it is the value of the variable such that the number of observations above it is equal to the number of observations below it. Let us take an example. Before going to take the example, first we have to follow some steps. Steps are to be followed while calculating the median. Step number 1. First, what we have to do in any example, arrange the observations in ascending or descending order of magnitude. Secondly, remember students, determine the number of observations and let them say n. And the third one is, let's say if n is odd, then we have to apply the formula median equals to value of the n plus 1 divided by 2th observation, and if n is even, then we have to apply the formula median equals to mean of the values of the n by 2th and n by 2th plus 1 observations. Now let us take an example. Find the median of the following data set. This is the data set, that is 12, 18, 16, 21, 10, 13, 17, 19. So now what is our first step? First we have to arrange this data in ascending order like this: 10, 12, 13, 16, 17, 18, 19 and 21. Here we have total 8 individual terms, or we can say there are total 8 observations, and 8 is an even number. So what we will do, we apply the formula of median equals to n by 2th observation plus n by 2th plus 1th observation. So here we have the value of n is 8. We put the value of 8 in place of n. So it comes to be like 4th observation and 5th observation. So here we have 4th data value and 5th data value divided by 2. Now here we have 4th data value is 16 and 5th data value is 17. We put these values, 16 plus 17 divided by 2, it comes to be 16.5. So we can say the median of the given data is 16.5. Moving to our next example, the median of the observations 11, 12, 14, 18, x plus 2, x plus 4, 30, 32, 35, 41 arranged in ascending order is 24. Now find the value of x. Moving to our solution part, total number of observations we have given 10. Since 10 is even, we apply the formula, that is n by 2th observation plus n by 2th plus 1 observation divided by 2. We put the value of 10 in place of n, it comes to be 5th plus 6th observation. And we have given in the question that median is 24. So what we will do, we put the value of 5th observation and 6th observation from the series, that is x plus 2 and x plus 4, and find out the value of x from this equation, that is 21. So the value of x is 21. Here we will do one more example. Find the median of the following data. If 35 is replaced by 60, what will be the new median? According to our rules or steps, what we will do, we simply arrange the data in ascending order. So my dear students, as we have seen in this question that the series has already been arranged in ascending order. So there is no need to arrange in ascending order first. We simply calculate the median of the following series, that is 19, 25, 30, 31, 32, 35, 48, 51 and 55. The total number of observations is 9 and 9 is an odd number. So we apply the formula of median is value of n plus 1 divided by 2th observation. We put the value of 9 in place of n. So it becomes like 9 plus 1 divided by 2th observation. So finally it comes to be 10 by 2, that is value of 5th observation. So from this series the value of 5th observation is 32. So our median of the given series is 32. Now according to the question we have given, if 35 is replaced by 60, then the series will be like this. That is 19, 25, 30, 31, 32, 48, 51, 59 and 60. Again there are total 9 odd numbers because the number of observation doesn't change. Why? Because the one number is replaced by the other number. So value of 5th observation is 32. First, second, third, fourth and 5th. So we can say after replacing the values, the value of median is 32. Characteristics of median. It can be calculated graphically while mean cannot be. Half of the values in the data set lie below the median and half lie above the median. That's very true because median is the center point of any given series. It is not affected by extreme values. That is, it is not affected by smallest or highest values. Applications of median. Nowadays, median is not used only in mathematical field but also in business fields also. For example, it is used for determining typical values in problems which are concerned with wages, distribution of wealth, etc. Let us take an example. An ad agency is planning an ad campaign for a city. Would they be more interested in the median or mean family income for the city? Obvious reason, the answer would be median. Why? Because a few very large incomes could drastically change the value of the mean as the average income in the city. Let's take in another example. A company wants to know if their customers rate their services as excellent, good, average or poor. Would the company be more interested in mean or median? Again the answer is median. If the numbers was assigned as 4 to excellent, 3 to good, 2 to average and 1 to poor, then the median as a center value would provide useful information. It is the only average which is used while dealing with qualitative data which cannot be measured quantitatively but still can be arranged in ascending or descending order of magnitude. Let's say it is used to find the average honesty, average beauty, average intelligence. Now moving to our next and the last component is mode. What is mode? Till now we have studied two measures of central value of a set of observations, that is mean and median. But in this section we shall study a third measure of the central value of a distribution, which is known as mode. So what is mode? It is the value which occurs most frequently in a set of observations, or in more simple words we can say it is that value of the variable which has maximum frequency. Let us take an example for this. Find the mode of the following data set. We have given the data set, that is 48, 44, 48, 45, 42, 49 and 48. Now in this data what we are seeing is 48 is the only number which occurs 3 times in this entire data, that is 48, 48 and 48, and the rest of the numbers, that is 44, 45, 42 and 49 does not repeat at all. So we can say the mode of this entire series is 48. Moving to our next example, find the mode for the following series. In this kind of examples, what we have to do, we simply make out the frequency distribution table for which about we have already studied. So here what we will do, we will make frequency distribution table. With the help of that frequency distribution table, we will be able to find out the mode. This is the table that we have given the values from 2.2 to 2.7. It occurs 4 times. We put the tally bars and frequency. According to the data we have given 4 times 2.2, 2 times 2.3, 7 times 2.4, 2 times 2.5, 1 time 2.6 and 2 times 2.7. So here we can say from the frequency column that 4 is the highest number. So we can say 2.2 is the term which occurs maximum, and the value of 2.2 is the maximum frequency, that is 4. So here we will say the mode of our given data is 4, not 2.2. If in these kind of examples we simply consider value of that term which is maximum occurred in the entire data, we see that the value 2.2 has a maximum frequency, that is 4. So finally we can say 4 is the mode of the given series. In these kind of examples we can say the mode is that value of the frequency which occurred most in the entire data. That is here 2.2 occurred 4 times in this series. Characteristics of mode. It is possible for a set of data values to have more than one mode. If we have given series like 2, 4, 4, 9, 9, then here we have two modes, that is 4 and 9. Second characteristic is if there are two data values that occur most frequently, we say that the set of data values is bimodal. If it so happened that there are two data values, then it is considered as bimodal. Similarly, with the first one, if there are two modes in the given series, then we can say that series is bimodal. Third one is it can be calculated graphically. It is not affected by extreme values, that is either by lowest value nor highest value. If there is no data value or data values that occur most frequently, we say that their set of data values has no mode at all. Let's say if there is a series from numbers 1 to 10, then the mode of that series is 0. Then the mode of that series is nothing. Why? Because 1 to 10 there are total 10 numbers and none of them has occurred more than once. Now, applications of mode. Basically, it is the average to be used to find the ideal size mainly. For example, we can say business forecasting, in the manufacturing of ready-made garments, in the manufacturing of shoes, in business charts, papers, in calculation of inflation, and so on. Let's take an example. Suppose a company is considering expanding into an area and is studying the size of containers that competitors are offering. Would the company be more interested in mean, median or mode for their containers? Answer would be mode. Why? Because they want to know what size tends to sell most oftenly. So in short, we can say the main and basic use of mode is to find the ideal size of anything. The mean, median and mode of a data set are collectively known as measures of central tendency, as these three measures focus on where the data is centered or clustered. To analyze data using the mean, median and mode, we need to use the most appropriate measure of central tendency. My dear students, always remember the next 3 points. That is, firstly, the mean is useful for predicting future results when there are no extreme values in the data sets. However, the impact of extreme values on the mean may be important and should be considered. For example, the impact of a stock market crash on average investment returns. Second, we can say the median may be more useful than the mean when there are extreme values in the dataset, as it is not affected by the extreme values. And the third one is mode. It is basically useful to identify the ideal size and when the most common item, characteristic or value of a dataset is required. The relation among mean, median and mode given by the following formula. That is, mode equals to 3 times of median minus 2 times of mean. My dear student, this is all about the entire chapter of stats and measures of central tendency. Now we will meet in our next section where we recall all the formulas, all the concepts which we have studied so far. Thank you.